Welcome to IDS KT. Let's explore an important topic shaping the future of defense and global security. I'm the founder and director of International Defense Security and Technology, a California-based nonprofit think tank dedicated to research and analysis on global defense, security, and emerging technologies. I also serve as CEO of Interplanix LLC, a New Mexico-based company advancing satellite risk analysis, orbital debris forecasting, and space security frameworks to ensure mission assurance and resilience. Previously, I served in leadership roles at India's Defense Research and Development Organization, DRDO. Most recently as Director of the Systems Analysis, Modeling, Safety, and Quality Cluster at DRDO Headquarters, New Delhi. This channel brings you deep insights into the global security ecosystem, from geopolitics and emerging military technologies to cyber, space, and system-level analysis of tech trends and their interrelationships. Subscribe and join us as we decode the forces shaping the future of global defense and human security.
Today, we are diving into one of the most promising tools in the global fight against climate change: carbon capture, utilization, and storage, or CCUS. This technology isn't just about sucking carbon out of smokestacks. It's about reimagining how entire industries like cement, steel, shipping, and power can continue operating while drastically cutting their emissions. At its core, CCUS works in three stages. First, carbon dioxide is captured at the source. That could be from a coal plant, a cement kiln, or even the open air. The most common method uses chemical solvents like amines to extract CO directly from exhaust gases. At Canada's Boundary Dam, for example, over 90% of CO emissions are captured using this technique. In newer applications, membrane filters and calcium looping are helping reduce the energy needed, making the capture process more efficient. Once captured, the CO has to go somewhere. Most of it travels through pipelines like those in Norway's Northern Lights project, which plans to move millions of tons of CO beneath the North Sea each year. In places where pipelines aren't an option, liquefied CO is shipped by sea or truck to its destination. In Japan, specially built carriers are already making this a reality. Then comes the big question: what do we do with all this carbon? That's where things get exciting. One option is to permanently store it deep underground in depleted oil fields or saline aquifers. The US has the capacity to store billions of tons this way. But increasingly, innovators are finding ways to use CO as a raw material. From turning it into jet fuel, to making stronger concrete, to growing crops in greenhouses, it's becoming more of a resource than a waste product. Projects around the world are proving that CCUS isn't just theoretical. Northern Lights in Norway is set to launch operations in 2024 and expand rapidly. In Canada, the Boundary Dam has already captured over 4 million tons of CO, and new methods like alkaline mineralization are taking hold in places like California and Finland, where waste carbon is locked into safe, usable materials. Breakthroughs are also accelerating the pace. Companies like Climeworks are pulling CO directly from the air. Their Orca plant in Iceland already removes thousands of tons per year, powered by clean geothermal energy. New materials from MIT are making capture faster and cheaper, and AI is being used to optimize everything from solvent use to underground storage site monitoring. One sector with massive potential is maritime shipping. It's responsible for about 3% of global emissions. But onboard carbon capture systems, or OCs, are starting to turn ships into floating carbon scrubbers. Retrofitting older vessels with compact carbon traps is now technically feasible and economically competitive, especially when combined with carbon credits or regulatory incentives. Leaders like Maersk and Mitsubishi are already piloting these systems. Still, the road to scale isn't without obstacles. Capturing carbon can cost anywhere from $50 to $100 per ton, and the energy required can eat up to 30% of a power plant's output. But tax credits and new technologies are closing that gap. In the US, the Inflation Reduction Act offers up to $85 per ton. Projects like Iceland's CarbFix are also showing the public that carbon storage can be secure and even fast, turning CO into rock in just 2 years. As we look ahead, the future of CCUS is starting to take shape. Policy, technology, and global collaboration are aligning to make it a cornerstone of industrial decarbonization. We are now seeing CCUS tied to green hydrogen hubs, renewable energy, and climate equity programs bringing jobs and carbon solutions to developing nations, too. At the end of the day, CCUS may not be the flashiest climate tech out there, but it just might be the one that holds the key to reaching net zero, especially in sectors that can't electrify overnight. It's not just a bridge to a cleaner future, it's a foundation for building it.